We are proving our last set of Pythagorean or of trig identities today. Cosine 2 theta is the cosine of theta plus theta. I just showed that that's cosine squared minus sine squared. So back, way back, do you remember that cosine squared theta plus sine squared theta was equal to what? 1. So what's cosine, or let's see, I don't want to do cosine. What is sine squared theta equal to? Solve for it algebraically. Sine squared theta is 1 minus cosine squared theta. Cool. So we can go cosine squared, keep that, and wherever you see sine squared, I can replace it with 1 minus cosine squared. So go ahead and do that. How many cosine squareds do we have if we go minus a negative cosine squared? 2 of those. And that's equal to cosine 2 theta. Wow. You got it. You got it. Now what we're going to do today is we're going to do something brand new. We're going to take this cosine in here to the first power, and I'm going to solve for that in terms of cosine 2 theta. So what would we do first algebraically to solve for the green? Add 1. So cosine 2 theta plus 1. Good. That'll be equal to 2 cosine squared theta. Now what? What do you want to divide by? Both sides? How about divide by 2? So you lose that. So now I just have cosine squared theta equal 1 plus cosine 2 theta over 2. And now I'm going to solve for cosine. What do I have to do left? Easy, just take the square root. Plus or minus, square root, plus or minus. So my answer for my identity here is the cosine of theta is the square root, plus and minus, 1 plus cosine 2 theta over 2. I did that before. 2 theta, not squared theta. Now I'm going to do something that you would not suspect. I'm going to replace all my thetas with 4s. Did you suspect that? No. I don't want 4s. How about 9s, 2s? How about 7s? Could I replace all these with 5 or 6s? How about x's? Could I replace them with x's? Sure. Well, I'm going to replace it with a x over 2. Just going to put anything I want for theta, but I'm going to put an x over 2. So that's going to change this cosine of theta into cosine of x over 2, which will be equal to plus or minus 1 plus cosine of 2 times x over 2 all over 2. Anything cancel out? Yeah, those 2's are going to cancel out. So goodbye. Ooh. We'll get rid of that. So there you go. That, right there, 1 plus x over cosine x over 2. This is what we call the half-angle formula. Half-angle formula. Pretty good. So you got one of them. 2 more to go. Then we're done. We're going to find the sine of x over 2 next. But we're going to be a little tricky here. I'm going to go back. I'm going to go right off of this. Do you mind? Cosine 2 theta was cosine squared theta minus sine squared theta. and I'm going to replace, I replaced cosine squared with 1 minus sine squared. What do you think I'm going to do this time? You're right. I'm going to replace sine squared with 1 minus cosine squared. No, that's what I did last time. Excuse me. I'm going to replace cosine squared with 1 minus sine squared. There we go. So what will that simplify to? 1, 2 sine, good, squared theta. That'll be equal to cosine 2 theta as well. Here's what I want you to do. Now, you've seen this done once. Let's see if you can solve for sine theta and eventually find out what the sine of x over 2 is. Good luck. When I solve here, I can subtract 1 from both sides. So I get minus 1 plus cosine 2 theta is equal to negative 2 sine squared theta. And then let's divide by negative 1, making this a plus. This will be a minus. This will be a plus. So I get 1 minus cosine 2 theta is equal to 2 sine squared theta. Now, what should I divide both sides by? 2. There you go. And then I'm going to take the square root of both sides. And so my answer is going to be sine of theta equals plus or minus square root 1 minus cosine 2 theta all over 2. Then I'm going to let theta be equal to x over 2. So we'll just substitute that in, and I'm going to get sine of x over 2 will be the square root 1 minus cosine x over 2 plus 1 minus. Anybody get that? Nice. It kind of works out, doesn't it? What if I want to do the tangent of x over 2? Ooh, that's tricky. No, it's not. It's just the sine of x over 2 over the cosine of x over 2. Okay. So how hard would that be? Not at all. Tangent of x over 2 is going to be square root. The sine is 1 minus cosine x over 2 divided by square root 1 plus cosine x over 2. And what happens to these over 2's? They're going to cancel to give you plus or minus square root 1 minus cosine x over 1 plus cosine x. Would you put a box around that? The sine and the cosine we had earlier. Those 3 new ones. Okay, take a deep breath. Exhale. You just finished all the identities that we'll be responsible for. You will not, here's how we're going to do it. If you're taking AP or IB math next year, you'll need to eventually memorize these. I want you to start memorizing them in class for us, but I might give you like half the period with and half the period without formulas, and so it'll help you to memorize them, but you won't be expected to memorize them on a test at this